Uh, Hello everyone and welcome to our second video in this series of monitoring using the Prometheus. In this, we are going to start with our second question for the interview, that is explaining a difference between the monitoring and the observability. Now, this is pretty important to understand the distinction between the two. The reason being because we have been exposed for monitoring for a long period of time, and monitoring and observability have been interchangeably used, so it does not really project what is the difference between the two. Now, monitoring being on the legacy side of the system is known towards setting up the matrices and setting up the alerts for detection of the failure mode. So basically, if we look, what question does the monitoring answer for us? That is, what is happening? Okay. So the characteristics of the monitoring will be the reactive approach. That is, it responds to known problems. Okay. What that means is like if you already know about the problem, then you can set up the alerts for it. The predefined metrics like focus on the specific and predetermined data points, such as your CPU utilization, memory utilization, etc. Then there is a threshold-based alert. That is, you need to know the threshold above which your system might be behaving, in a reduced way, like reduced performance you are getting. So you can put on the thresholds and then get the alert for it. You can create a dashboard centric, which allows you for the visualizations of important metrics, and knowns and unknown. It addresses the problems which you might occur, right? So this is what the traditional monitoring actually does. So some of the examples will be the CPU monitoring, CPU usage, memory usage, response time, right? Now, there are various limitations with the traditional monitoring. That is, you cannot help with the unexpected failures, okay? And it basically limits down your, it's limited to your predetermined scenarios. That is, if I know that there can be a CPU failure, then I am actually dealing with it. And in this way, I need to know that CPU failures occur and I'm monitoring it. So what happens if something other than the CPU starts failing, which I might not be that much aware of. So I need to have some ways to gather the metrics, and this is where the Prometheus actually excels, and it overcomes these limitations. And then there is this traditional monitoring is difficult to understand and complex and interconnected issues. It often results in alert fatigue. What that means is you might get false positives and too many alerts might be there, which might not always represent the problem. That is where the alert fatigue comes into the picture, and it struggles with the modern distributed system. The major point of contention here is that when we talk about the distributed system, then we are going to deploy the newer services over incremental point in time. In the case of traditional monitoring, there is no such thing like service discovery. So you need to put on the alerts for each and every service that you are deploying, which increases the friction points and the manual things that you have to do. While in case of advanced monitoring like Prometheus, service discovery plays an important part, and it can automatically discover and put the CPU-based alerts and the conditions that you have pre-built into it. So these are some of the limitations that we see in the traditional monitoring approach. Okay. And there are various examples of it, Nagios, right, like that. Now, if we talk about the observability, right, observability is our ability to understand the internal state of a system by examining its output. What that means is, why is this happening, right? That is the major question which observability tries to answer. So if you look at the characteristics of the observability, it's a proactive approach, okay? If you remember, that was a reactive approach. This is a proactive approach which helps us discover the unknown problem. It has a comprehensive data collection. So it allows you to gather wide variety of telemetry data. It helps in correlation and context. That is, it connects you to the different data sources for insight. So if you drag on a dashboard, it points you to all the different graphs which have been created. So it allows you the correlation and context in that way. It helps in exploratory analysis. That is, it enables for the investigation of unexpected behaviors. Okay, and addresses the unknown. Now, there are basically three major pillars of the observability that we have to deal with. First one is the metrics, another one is the logs, and third one is the traces. And you will see that most of your observability will revolve around these major pillars. Okay. So if we talk about the metrics, this is basically the quantitative data that we are dealing with. it has numerical measurements over the point in time. That is, it has these different data points for the different metrics that we are going to gather. Example, CPU usage, request count, response time. So it has a wide variety of these resources for which we are collecting the data points and putting it on the basis of a time period. Over a period of time, we are gathering all these and mapping it to the time series like this. And aggregated data that shows trends and pattern. Now, this is very important that the metrics that we are collecting, that is the quantitative data that we are collecting, it allows us to present the data in the form of trend and pattern. Now, why is this important? Because in order to understand the behavior of our overall system, this will allow us to project the graph. And if you will see that there is a consistent behavior of a graph going, let's say, in a smooth line, that means it's pretty much how your system is tend to behave. But if you are seeing some spikes, that means this is where your system state is getting affected. So these kind of trends and patterns helps us understand this is where the metrics plays a very important role. Next is your logs, that is your event data. Okay, so there are discrete events which your applications might be handling, your system might be handling, right? And all these applications, the systems, there are many places where the logs keep on generating. And these logs have very important and vital information in the sense that they collect your error message, user actions, system events, right? Now, if you are analyzing all these log data, then you can have a detailed context about the specific incident. And most of the cases, you will be correlating between your metrics, your logs, and so on. And this actually extends to traces as well. That is, if you are working in a microservices kind of architecture, then all these microservices are relaying out the log, right? And you will see, because the request is going from one microservice to another microservice to another microservice, so you need to trace where the actual latency. So suppose there are 4 microservices interconnected before our request comes, right? I'm seeing the latency. Then how will I determine which of my microservices is getting affected? This is where traces comes into the picture. This is basically the request flow data, okay? And what traces does is, it shows you the path of the request through distributed system. Example can be microservices, call chain, data queries, right? And basically it helps you determine the performance bottlenecks and the dependencies. What this means is, suppose if I'm getting a latency high, then I can, if I'm having a traces data, I can pinpoint like how much time my request is taking from one microservice to another like this. And wherever I'm seeing the significant delay in the latency, that means that is the microservice which needs optimization and so on. That is where the traces plays an important part in a distributed system. That's why these are called as the 3 pillars of the observability. That is your metrics, logs, and traces. Okay. Now, if you wanted to see a key difference, let's say we try to compare between the monitoring and the observability. Okay, so this is how we can compare. Okay, so purpose of the monitoring is towards detect the unknown problem, and observability is more towards understanding the system behavior. Okay, for the approach towards the traditional monitoring is reactive, while observability is proactive. Data type, it's predefined metrics. While observability always has a comprehensive telemetry data. What that means is, in case of monitoring, we used to create a predefined metrics for CPU, memory, and that is where we are creating the alerts as well. But in case of observability, you will see it comes with a predefined set of data which gathers overall in the form of a telemetry. And then you can go ahead and analyze all this telemetry data, and depending upon your own requirement, you can set out the alerts. But all this data as a comprehensive way is available to you in the form of an observability whenever we are dealing with the Prometheus. Okay. Then there is the problem solving. Okay. If we deal with the problem solving, monitoring always deals with the known failure modes, while observability can be helpful in unknown issues. So if I'm getting a issue, right, and I have pre-built dashboards, I can have different matrices. So I can, if I'm correlating, let's say I figure out some CPU usage and I wanted to check out the inode count and those kind of metrics, right? So even though I might not have created in the dashboard, but that metrics is still available to me. If I wanted to check the spike in the inodes at that point in time, definitely I can go and look into them because that metrics is already available with the Prometheus like that. Next is your tools. So traditional monitoring comes with dashboard and monitoring, while if you look at observability, it is a complete set which comes with metrics, logs, and traces. Then if we compare about what question is answered, what is broken. Monitoring deals with what is broken actually in what point in time. It gives you the idea, and then you can go ahead and take a look. And observability gives you why is it broken, right? It has all this comprehensive set of metrics which allows you to answer that why is it broken. Now, if you deal with the complexity, it has simple threshold based. While if you look at the observability, it's complex correlational analysis where we can correlate one metric with another and so on like this to understand the root cause of the issue. Okay. So observability in practice, like let's take a real case scenario for let's say we are dealing with a e-commerce such as Amazon, Flipkart, or Paytm, or etc., and check out that the overall e-commerce website is working slow. Okay. Now, if we look at the monitoring response, the dashboard shows us that there is a response time which has increased. This is kind of a monitoring response, right? And an alert is fired which says, you know what, checkout response time is greater than 3 seconds. So that is the kind of latency that we are observing in our system. Then team knows that there is a problem, but don't know why there is a problem, right? So our traditional monitoring tool is giving out an alert saying that there is a problem, but it does not lay out the root cause of it. And this is where observability response comes into the picture. Now, this metric shows the response of a spike that correlates with the database query time. Okay, when we are checking with the observability, we see that, you know, some database queries are taking more time. And then the log reveals that there is a specific SQL query that is taking longer than usual. This can usually be coming into your slow query. Okay, so these kind of slow queries we can log, and then we can actually take a look into it as well. Then we run a traces, and on the basis of traces that we see there's a bottleneck in the payment service database connection. Okay, so team can identify the root cause. That the database connection pool of exhaustion, that is number of database connection which might be open simultaneously running the parallel, the queries is getting maxed out and stuff like this, which is causing the problem. Now, if you compare both of them, you will see that first part where we are dealing with the traditional monitoring, it gives giving us an alert saying that there is a problem with the system, but it does not tell you the root cause. While if you are running the observability along with the 3 pillars which we have dealt with, it clearly shows you that there are 3 of the things through which we are able to correlate and actually able to pinpoint the root cause of the issue. That's why observability takes an edge over the traditional monitoring. Now, if we deal about like, okay, what is the Prometheus role in monitoring versus observability? Okay, now Prometheus acts like as a monitoring tool, that is, it's primarily focused on metrics collection. Okay, so it collects all these different types of matrices and makes it available to you for the alerting. And then it excels at the time of series data storage and query, provides you robust query capability and dashboard to show you current and the history of the system state like this. Okay, so this is basically how the Prometheus is acting like a monitoring tool, because it's able to collect your matrices, it's able to store that matrix in the form of a time series data, it's able to provide you the alert on basis of that matrix, and able to project the graph also, and allow you to compare that data with the historical data. So all of these together makes Prometheus a monitoring tool. Then Prometheus, how does it contribute to observability? So Prometheus basically provides you the metrics pillar of the observability. Its rich labeling enables you the correlation across different dimensions. Now, this is very important because you are able to put the labels across the metrics. That's why it's allowing you to correlate with the different dimensions. And then you can run the PromQL, which allows you to do the complex queries to uncover the hidden pattern. Okay. So using the PromQL, I can go on writing the complex query through which I am able to query the large set of data. It is returning back me the result, which is not possible in the traditional monitoring in that sense. And it allows us to have an integration with the other tools, which completes our observability set. Okay, so that's how you will see that the Prometheus is acting and contributing to us in the form of an observability, which is pretty important for us. Now, building a complete observability with Prometheus includes your metrics layer, okay? And now when we say the metrics layer, right? So that metrics layer in the Prometheus, you can see some examples over here, okay? Basically how it works. So using the PromQL, okay, which the Prometheus actually understands and it's native to Prometheus, you can actually calculate the rate of request over a 5-minute point in time. Then you can calculate the histogram of the request duration, like how much time the request is taking, and you can create a histogram around it. Similarly, you can calculate the CPU usage percent, memory usage bytes. So all of these are, what is this? This is allowing you to help in the metrics layer. Okay. So this part is basically allowing you in the metrics layer. Now, if we come down to the logging layer, this is where the ELK comes into the picture. And this is important because you will see that all the systems are relaying out the logs. So we need all the logs into one location so that we are able to correlate with them. And this is where ELK system, like that is your Elasticsearch, Logstash, and Kibana comes into the picture and plays a very important role. So here you can see an example where the ELK is showing, a log is showing that there is a timeout which is happening at the payment gateway level. Okay. And then there is a Jaeger. Jaeger or Zipkin, these are basically the tracing tools which are available. Okay, and it basically shows you the spans which helps, which actually occurs between the different microservices. Whenever a call is going from one microservice to another, that is where it is showing you the span. Okay, and each span, like one track, there is a track ID through which you can track the request, and that track ID can have multiple spans depending upon how many microservices you are having. So suppose in this case we are having 3 microservices. So the first happens from checkout to the payment service, which took 250 milliseconds. Then from payment service, it goes to the database, which took 2.1 seconds. Now this is where you see this is a pretty big time, and that's where we are finding the bottleneck. So you can see that tracing actually helps us pinpointing the microservice, like where is the actual latency being happening, right? And then we can see from payment service to payment gateway, a timeout is occurring. Okay. So with the help of tracing, we can actually determine at the microservice level how much time and the request, or what is the status of the request which is happening at the each microservice level. That's why you will see that Jaeger nowadays plays an important role, especially in the case of the microservices kind of an infrastructure. Okay, let's take one integration example as well. Okay, so if you see integration example, here is a complete observability stack. Okay, so what is happening? Prometheus is gathering all these metrics and providing it to the Grafana for visualization. Okay, so we have been dealing with the Prometheus, which basically deals with the metrics, and all the metrics are collected by this Prometheus. Now, it is important to understand what is Grafana. Grafana is a visualization tool. That is, you generally use them together in the form that Prometheus handles all your data, but all the visualization, graphing, and that sense, that is being handled by the Grafana as your visualization tool. So Grafana can connect to the Prometheus data sources, and then it can project all the metrics which are provided by the Prometheus and display into the Grafana in a more visualization format. Okay, you have to remember that Grafana cannot work in isolation without the Prometheus, in that sense that it requires the data point. It might be provided by some other tools, but yeah, Grafana is only for the visualization perspective. Now, Prometheus, based on this metrics, we can narrow down to the logs, and logs we are going to be connecting it with the Jaeger, because whenever we are saying any log, we tend to associate, you can directly have a mapping with the Jaeger, and that way it takes you to the log. Suppose you find an error, so it will take you to the Jaeger traces, and there you can actually search with the trace ID of that which is coming into your log, and that's how you can correlate with it. Okay, and lastly, once you have identified the issue, it will go on to the alert manager, and that alert manager will be forwarding it to the PagerDuty or Slack. So this is the general architecture for the observability, how it looks like. Okay, so what are the benefits of moving from monitoring to observability? Okay, so if you see, it helps in faster resolution time. Now, because we have all these metrics, which we have correlations which exist, so it reduces our mean time to detection, right? MTTD, which is a very important aspect of the observability. So you will see that you need to continuously reduce the time of the actual detection. That is when you are able to narrow down the problem and identify the root cause for it. Then next come your MTTR, which stands for mean time for resolution. Now this is important, that how much time you are putting towards once you have identified the issue. Okay, so I need to take a corrective action, how much time I am taking to resolve the issue. That is where the MTTR comes into the picture. So reducing it again becomes a primary importance in case of the observability. Then you need to have better understanding of your system dependencies. Okay, so together you will see we have a faster problem resolution when we are implementing the Prometheus in our environment. Then there is a proactive issue prevention, that is we are identifying the issue before it becomes critical. Okay, and we are trying to understand our overall system behavior and optimize the performance based on the insights which we are getting from the Prometheus metric. Okay, so overall from the graph perspective also you can take a look and determine, okay, this is my normal behavior and this is the time which I am facing the issue and this is going away from my normal behavior. So that kind of proactive approach can also be taken. Then there is a better system understanding in terms of the comprehensive, because now you are having a more comprehensive view rather than just looking at the CPU and the memory and stuff like that. You are able to put across the different metrics, and then you can project the graphs and understand any behavior of your system or the application that you would like. So it's a more comprehensive view of the overall system interaction. And we have a data-driven decision making. That is, we are raising the alerts, or we are trying to correlate based on the data. Now, this is very important. We are not putting some assumptions or things, okay, this can be wrong or that can be wrong. We are actually having a data-driven decision making. And this allows us to improve our overall architecture and design decisions as well. So you will see these are all the advantages of having the observability, and that is how your monitoring compares to your observability. I hope this provides you a clear differentiation, all the important aspects of the observability, all the pillars, and how observability is put into the system, and then you can better relate to the observability and all the advantages that you get out of the observability as well. All right, so that's all for this video. I hope you like this video. If you do like, do subscribe to our channel, and all this data is available directly on our blog, which is unixcloudfusion.in. You can directly visit there. You don't need to take the notes for this video. Okay. All right, that's all. See you in next video. Thank you.